Hello, thank you for being here. I'm very happy to present in such a great conference with a great audience, and it's a bit special session because we have among the audience Bob Lord from the Twitter security team. So let me start my session about Twitter API by introducing myself. So a few random facts about me. My background is iOS and Cocoa development. So I write programs for macOS 10 on the iPhone and iPad. My degrees are in software engineering, but I also have a master's degree in economic crime investigation, and I work for a bank in Switzerland. I've been using Twitter for 5 years. Maybe if you are a Twitter user, could you raise your hands? Okay, so I would say more than 50% of you use Twitter. Maybe it's because you're in this session. And also I have a 10 months baby. He's 10 months old today. So I love this slide because it summarizes who I am and what I do. It makes me laugh all the time, but this is really what my friends think I do. And this is what I think I do. And this is what I actually do. I spend a lot of time in front of my computer, and one day I decided for fun to write a pet project, which was a Twitter client. So that's why that was my prime motivation for this research. So as you know, Twitter is not exactly a startup anymore. It grew up very, very quickly and in a huge way these last couple of years. And what is of interest for me today is the API. Imagine you are writing a Twitter client. What you are interested in is the API, but you have to understand the changes through Twitter to understand the changes in the API. So back in the days, you could access and post tweets with basic authentication, and then Twitter introduced the OAuth API. And since last month, you have to use OAuth API version 1.1, which requires every request to be signed. Additionally, Twitter has changed the rules for displaying the tweets. You have to adhere to very strict rules. And in terms of service, you have to display the tweets exactly this way and in no other way, or it will be an abuse of the API. You have to display the timestamp in the bottom left. You have to display the logo in a certain way. And you also have a couple of additional limitations related to your Twitter client. For example, your Twitter client can never have more than 100,000 users, or the additional users just can't log in. So in a general way, Twitter discourages Twitter client's development. It is Twitter's policy, right? Okay. So what technical means Twitter have to enforce this policy? Well, since last month, every request has to be signed with some form of private key. And if your application does not respect the terms of service, then Twitter will simply revoke your keys and your application will stop functioning. So that's how Twitter controls and enforces his policy. But of course, if you think about it, what from Twitter point of view makes your request seem legit or not? How can Twitter know that some request is coming from the Twitter application for macOS 10 or for Twitter application for Android? Okay, the idea behind that, you have understood, is that if you can spoof somehow the way that some legit application sends its request, then you would be able to write your own client that would look legit from Twitter, but would be, in fact, a rogue client. So the question is it possible? So of course, is it possible? But to understand how we can do that, we have to see exactly how Twitter uses OAuth. I like this picture because OAuth is a pretty complicated process. It mixes authentication and authorization And you have different scenarios that can expose a couple of vulnerabilities. I will explain after the problem from a security standpoint. But for now, I will just present how Twitter uses OAuth. And to show you, okay, we could browse the RFC, but it's not very funny. So I tried to explain graphically what's going on with this notation. Okay, so this is a client, this is a server, this is Twitter, right? And here, the client sends a request token. A token is just a string, basically. It's a value encoded in a string. And this is a response. So in this case, we send the yellow token, and we get back the blue token. And here is the same thing, but the request is signed. It's signed with this green star, but the green star is never sent. It's just used to sign the request. Okay? It is just the notation I'm going to use to explain you Twitter's usage of OAuth. Well, the first case is, imagine you have some kind of, you have a third-party service on the internet. Here I chose Bitly, which is a bookmark manager, or I don't even know exactly. But it could be any service on the internet. So you want to authorize a service to use your account. What's going on? You ask the service to use your account, then Twitter will return you a URL with request tokens. You will authorize these request tokens, and the third-party service will get back this verifier token. And if you think about it, at this point, the third-party service can prove Twitter that you have authorized him to use your account, but you've never sent your password. You've never given your password to the third-party service. So that's what OAuth is about. You have authorized a third party to use your account, but you did not send your password. At the end of the process, what is important is these green tokens. This is indeed the access tokens, which are used both for signing the request and sending the public part, the public token, to interact with Twitter API. So this is the first case when you have a third party. A second case is a variant of this. So look what is changing here. This is a case of a desktop client. Imagine you are using Twitter.app for macOS 10. This is a transaction it could do. So it's basically the same thing, but the requests are not sent from the third-party server, but from the client on the desktop. You could wonder why it is so complicated. Why do we have three phases authentication? It could be just as simple as sending your login and password, or maybe hashing or use digest authentication. Well, there is a variant. It's called OAuth. In OAuth, it's just one phase. You sign the request, and you send along your username and password. You have to send them somehow over the network. And Twitter directly responds with the access tokens. And then you can interact with the API. There is a last use case I'm going to present. It's very recent. It was introduced, I guess, last month. And it's called the bearer token. It's a bit special. Imagine you want to make requests which are not without user context. You could have an application reading a public timeline or doing searches, but not allowed to access direct messages or post a status. It goes this way. You send these two tokens here, and you get a bearer token. A bearer, it means that when you are holding this token, it's OK. You can perform requests with Twitter and get a timeline. And you can also invalidate the token. I will come back later on the security implications of this. So I tried to present graphically what's going on in the 4 cases of authentication when you authenticate with OAuth to the Twitter API. So you've noticed that in all 4 cases, we used these tokens here. They are very important. They are the consumer tokens. It is values that are embedded in the application. if I use twitter.app for macOS 10, these values are part of twitter.app. They are part of my binary file. They have to be in the first place in the binary so that I can start all the OAuth process. It means that if I have this this red and yellow tokens, I can impersonate the client who holds these tokens. And I can do all these kind of authentications by spoofing its identity. So I would like to show you how is it to rip off consumer tokens from legitimate Twitter clients. In fact, maybe you're here because you're interested in Twitter, but I will show you techniques that you will be able to use in your own research, in your own projects, which are not necessarily related to Twitter. It's just because it's fun and nice and very effective techniques. So the first technique is the most obvious one, maybe. So you all know the strings command. It's a Unix command that dumps the strings, the printable characters, in a binary file. So it turns out that you can simply dump the consumer key, consumer token from the Twitter official application, official client for macOS 10. So it's not even hacking, it's just reading in the binary, right? So we could test the tokens. Are they valid? I tried to put some demos in my talk. I could have recorded everything, but it's much more fun live. So this is a script, a Python script, which will just test the tokens which have been dumped from the Twitter binary. If I run the script, I get an authorized URL. In the slides, we've seen that we are in this case. I got an authorized URL. I will authorize with my Twitter account, and I will get a pin that I will send back to Twitter, and I will get the tokens at the end of the process. So here we go. I open this URL in a browser. So Twitter has recognized the consumer tokens from Twitter for Mac. And basically, I just wanted to show you that it works. It is really the tokens. So I authorize the app. I will get a pin that I will copy in my terminal, and I will eventually get the access tokens. Okay, try again. Okay, never mind. What you saw is that the consumer tokens we extracted were really the ones from Twitter for Mac. But in many applications, in many Twitter clients, the strings, the consumer tokens, are not simply put in the binary file. They are somehow hidden or obfuscated. So you have to use other techniques to retrieve the tokens. And one technique is obviously to use GDB. So in GDB, you would do something like this. It's a dynamic technique. I am not speaking about IDA or static reverse engineering techniques, which are much more complicated. I'm just presenting some very efficient and simple techniques, but they are dynamic techniques. It means that you have to interact with the program to extract the tokens. What we are doing here is that we're putting a breakpoint on the function. It is Objective-C code. If you've never seen that, it is a class or the instance, and this is a method. So it means that I'm breaking on the method that will return the consumer key and the consumer secret. On which process? On OS 10 accounts daemon. It is the process that handles the macOS 10 Twitter account. And if you can read the GDB, then you see that I'm breaking on the function. I just finish the function. I say, when you need consumer key, OK, break, finish the function, and read the return value of the function. And that's it, and it's a token. I'm going to, so this is the consumer key and consumer secret for macOS 10.8. They have not leaked. You can Google them. They are not public. So don't worry, I released my slides without these values. But my point is that anyone can find them. I will discuss afterwards the security consequences. Maybe I will do another demo. I will extract, with the same technique, the consumer key and secret from iOS 6. How would I do? Well, I can simply launch the iPhone simulator. So I have a simulator of iOS 6 running here, and there is, I'm in the application OAuth settings, if you want, and you can enter your Twitter account. It is integrated in iOS 6 and 5 also. So what I'm going to do is I am going to attach the PID of this process of accounts D running in the iPhone simulator. So the PID is this one. So here we go. OK, now I want to break on the very function that will return consumer key and consumer secret. If I don't know them, I can look for them with infofunc, maybe consumer. Good. I found the Objective-C method that will return consumer key and consumer secret. Then I put a breakpoint here. I put another breakpoint here. And I continue running the program. Now, what I have to do is that I have to interact with the program and set up a Twitter account, real or fake. It doesn't matter. What will happen is that at some point, the program will require the consumer key and consumer secret, and my debugger will break. So I enter something. The debugger breaks. And so you can see the backtrace. I'm here. So I will let the function finish. And I will print the return value of the function. So this is the consumer key of iOS 6. I continue. I break in consumer secret. Same trick. Finish the function. Print the return value. And this is the secret key. So as you can see, it's a very effective technique. And you can use it, once again, for many other things, for maybe your own projects. But sometimes you do not have the address of the function that will return the consumer key or secret. How would you do then? You have many other techniques. So one I like most is dumping deallocated pointers. This is, I tried to represent simply, so the binary file that we somehow analyze statically with the strings command, but once it is loaded into memory, you have the memory, so what can you do? Where can you find the tokens? Well, the idea here is to dump every pointer that will go through the free function. And the trick is to use a dtrace probe. Maybe you know dtrace. It's a process running from the kernel user space, and you can write simple instructions with a kind of subset of the C language. And this command is very, very simple, but so effective. I love it. It's hard to imagine something more simple. I will show you how to log every data that goes through the free function. And I'm going to use it to capture the keys for macOS 10. So I just have to find the PID for accounts.d running on my macOS 10. Well, here it is. And here we go. So I have to interact with the program, with the process. What I will do is I will enter a Twitter account. Whoop, Twitter. It's my test account. My regular account is NST021, and my test account is 022. Sign in. OK, I'm not on the right network, sorry. The idea here is that at some point, the application will use the consumer key and consumer secret to sign the request that will be sent to Twitter. And then it will get deallocated, and at this point, I have dumped the string. So here we are. Here is some random data that went through the free function, but when there were strings, they are simply logged. So can we find the keys for macOS 10 here? So I'm cheating a bit because I know the keys, just to show you that they are effectively among the strings that got dumped. So this is the consumer secret for macOS 10. So yep, it was a very, it is a technique I love, and you can apply it to many projects. But in real life, maybe on macOS 10, you would use the Objective-C capability of injecting code in a running process this way. What are we doing here? I'm using GDB. I'm not going to demonstrate it, but I want to mention it because it's very easy to do. You can compile this code into a framework and that you will load dynamically in the process address space. You take advantage of the Objective-C runtime capabilities. You dynamically load some code. And what does this code do? Well, you're adding a method to NSString, and you're replacing the deallocator method, which is called a dialog in Objective-C. You're replacing the regular dialog with myDialog, which does exactly the same, but just before calling the regular method, it logs the string, which gets deallocated. So even if you try to hide the keys in the application, there are many very efficient and simple techniques to find the keys. So there are many other techniques. And another one I love is simply dumping the whole process memory. Once again, the idea that at some point your application has to use these keys for computations and signing stuff, so it has to get into the memory. Even though a value, a string, would get never deallocated, at some point it resides, it lives in the memory. So if you dump the whole memory content, you will see it. In macOS 10, on other platforms like Linux, GDB has some capabilities to do that, but it doesn't work on macOS 10. On macOS 10, what I found is that you can use gcore64, which is a third-party application, if you want, that is part of the book macOS 10 Internals from Amit Singh. So you just give the PID of the process, and it takes quite a lot of time because the memory can be quite big, and it dumps an object file with everything in it. If you want to run a strings command, you have to clean up the header so that it's not recognized as a binary file, and you can run strings. And so I'm dumping here a binary file, and I'm taking out the strings from this binary file, and the sort U is sort unique. So I'm extracting the strings and making each string unique so that the file is much smaller. And we know from Twitter API documentation that the signing key must be a consumer secret appended with an ampersand. So you can easily write some regex that will extract this pattern, and you will very easily find the keys. So yet another way to find the keys is to Google for the keys. You just type consumer key, consumer secret, and it turns out that many application developers upload their keys on GitHub or Pastebin, or it's very easy to find. Well, I'm talking for 30 minutes. I wrote 20 minutes. So maybe this is not very important. What is important is that, so to understand the in and outs and really technically how things were working, I wrote my own Twitter library for macOS 10. It's called st-twitter, and basically you have 3 ways to use it. You can use the regular account that was entered through macOS 10 preferences. You can use random consumer tokens you have found, and you can also use app-only authentication. This is a front end from my library. It's just a test front end. It's not a real Twitter client. And I wanted to demonstrate you, but I can show you. The screen is too small. I cannot access the fields at the bottom. So I will just explain you what it does. Basically, you choose the identity of Twitter client because you've extracted consumer key and consumer secrets. For this application, you choose your application. You can log in, you can access the timeline, and you can post. I just wanted to do a demonstration by posting with these coordinates, which are actually Fukushima nuclear reactor coordinates, but it was just for fun. It was just to show you that when you write your own Twitter client, you impersonate a regular one by stealing the consumer key and secret, and then you are free from Twitter's term of service. And by the way, this library is going to be integrated into Idiom, which is a multi-protocol chat client for macOS 10. So I've tried also to write my own Twitter client. It's a bit of pet project. It's an alpha project. It doesn't really work, but it let me experience with fun ideas like giving a score to each tweet based on the author or the keywords in the tweet, and representing the scores here in a kind of chart. What you could do also is, because you are now free to present information as you want, so you could represent discussions graphically. This is also kind of a side project, but related to Twitter. This is a way I found to encode binary information into tweets. The idea here was to pack binary information, to transfer binary information into Unicode, into Chinese characters. And with this kind of tricks, it turns out that you can pack 164 bytes in 106 characters. This is a tiny macOS 10 executable file that can be represented in a tweet with this trick. In fact, if you're wondering, what I do is I take 12 bits, transform in a Chinese characters, then 12 bits into a Chinese characters, and then you can stuff 3 bytes into 2 Unicode characters. Well, okay, I'm going to speed up. So I've tried to explain how Twitter is using OAuth. I've tried to show you how to rip off consumer tokens and consumer secret from applications. And now I'm going to discuss the situation from a security point of view. So first, I think that it was somehow an error to transpose the situation on the web with this third-party server to the desktop. Because here, this consumer secret was used by the third-party server. You could not access it. But here, when it's running on your desktop, anybody with time and skills, and little time and little skills, can find this consumer key and secret. I don't find it very realistic that Twitter can revoke leaked keys, because especially keys for important and widespread systems and applications like iOS or OS X, because if Twitter revokes the keys, nobody will be able to use Twitter until the next software update. I'm also not convinced that OAuth is much better than HTTP DGS authentication. In OAuth, client application don't need to store the password, so it's a good point for OAuth. But at some point, OAuth sends also the passwords in the first request. Also, about this app-only authentication, something is ineffective and dangerous. Because what's going on here? If you can extract the consumer secret and consumer key, then you can get the bearer token. You can use it again, and exhaust the limit, which is set by Twitter. So this is an effective denial of service for this application. For the application, you have taken the tokens. But worst, you can also invalidate the token. And imagine an application which would ship with the bearer token inside. If you invalidate the token, then all the instances of the application will stop working. It's why I think it's I don't think it's such a good design. I think that OAuth is a pretty complicated process, and we've shown that it's not able to reliably identify the client. And additionally, it puts the user at risk. Imagine somebody who, well, is a Twitter user, but is not a hacker, or is not a programmer. He loses his iPhone. He will change his mail password so that the thief of the iPhone will not be able to use the mail. He will change his Twitter password so that the thief will not be able to use his Twitter account, but he will, because changing the password does not revoke the access tokens. So this is OAuth. It's not intuitive for users. And as the process is convoluted, it exposes vulnerabilities. And I will show you a very bad vulnerability. Here it is. Maybe I do the demo. It's more effective. So what I'm going to do is choose some application which I know that is badly configured. I will choose TweetDeck. And because also TweetDeck is property of Twitter, I think. It was bought by Twitter. I'm going to specify a custom callback. And I show you the slides in parallel so that you understand what's going on. I did this first request, and I got the blue tokens. And I'm going to trick a victim to authorize these tokens with his Twitter account. So look, these are the blue tokens. OAuth token secret. I can post this URL on a forum. I can write a mail to my victim and say, OK, check out Twitter, check out somebody's account. I don't know. The point is that the victim will open the URL. It arrives on, OK, I'm not logged. Sorry, I just have to log in before. OK. So I'm the victim. I'm logged as NST022. You can see. I click on the link. I'm on Twitter website. Everything is fine. I see the log. HTTPS, perfect. TweetDeck, I trust. I authorize the app. Fine. I'm on my Twitter page. Perfect. But what happened is that, in fact, I redirected. You remember, I wrote a custom callback. So I redirected the authorization token to my server. I sent me an email, and I redirected the user to Twitter. So for the user, he's still on Twitter web page. He has not noticed anything. But in my email, I have received this verifier. And this verifier is the pink one here. So what I can do is use it to log in and get the access tokens for the user. And can I show you? No. Yes, get timeline. I'm using the account from NST022. So I'm the pirate. I tricked NST022 into authorizing these tokens, and he did not notice anything, but I can now access his account, post on his behalf, access his direct messages, and so on. The risks, they are obvious, but I chatted last night with some of you, and he said, describe the risk. So the risks are you can maybe eventually hack a news agency or some company and announce a profit warning and sell or buy stocks, or I don't know. You can make fun of your favorite politician or blackmail people with direct message. Well, things can go bad. So my conclusion is that I'm not sure that OAuth is a very effective way to enhance Twitter's API security. I understand why it was done, but the reality is that it's too easy to cheat. And since it is complicated, it exposes new vulnerabilities. And I'm not sure it's very easy to do to maintain an API open to third-party clients, but allow some clients and reject some other ones, since the clients are running on the desktop and can be subject to analysis. So it's a tricky problem. Okay, I just have 3 bonus slides I wanted to show you because we have time. Okay, I found this picture was fun. I Googled for Twitter Amsterdam and I found it. So it's not really related to abusing Twitter API, but more Twitter clients. I found a couple of weeks ago, maybe, that this sequence of characters, this is Unicode characters, 1, 2, 3, 4, 5. You have 5 Unicode characters. They make OS X clients crash. If you write this in a terminal, the terminal will crash. Mac OS X cannot represent these characters and makes the whole process crash. So the idea here is that if you are able to send these characters on Twitter, what will happen with Twitter clients on Mac OS X trying to display this string? So let's try. So this is a script. I'm going to post this sequence of character. Maybe before I will start, so this is Twitter official client for Mac OS X, and I'm going to post my crashing characters. This is NST021 account. Following NST022, I'm posting on NST022 account, and look, I crashed Twitter application because it cannot represent correctly the string I've posted. I can try to start it again, it crashed. Again, it crashed. I can start another Twitter client for Mac OS X, Socialite, it tries to get the tweets, it crashed. So it's not really abusing Twitter API, but it's still abusing an OS X vulnerability in some way. So this is a stack trace. And that's it, I'm over. Thank you for listening. This is my regular Twitter account. I won't post anything dangerous on it, you can follow me. And this is an article I've written explaining all the details, and you have all the references on my source code. Everything I did is public and so. I just didn't put the full keys in my slides, not to be embarrassing for anybody. But I hope you enjoyed, and once again, my point was to present my research and also give you some tools and ideas and techniques you can use for your own research. Thank you.
We have some time left, so if you have any questions for Nicolas.
Just a quick question. I assume that you don't recommend using Twitter clients, using the web interface?
I'm sorry, could you repeat?
You recommend not using Twitter clients and just using the web interface to try to get around these types of issues, or?
No, I'm not aware of specific issues using Twitter on the web. I didn't look. It would be interesting to know if access tokens are sufficient to interact with the web, Twitter on the web, but I didn't research this part.
Okay.
Any other questions? No? All right. Well, I want to thank you very much, Nicolas.